So good morning, welcome to Nuremberg. My name is Kevin McDermott, I'm with Imperas Software. We're a small UK company and we build development systems to help people simulate a processor, write custom instructions and profile and analyze. So within the RISC-V architecture, this is a new architecture that supports custom instructions. So I'm going to give a short presentation how to build custom instructions with the RISC-V. So an agenda, why do we want to do this? You may have read about RISC-V. Many people are adopting RISC-V as a new architecture. They're using it for many reasons. To develop internal cores, to develop a new business model, to develop new custom devices, use it internally as custom instructions. And obviously there's ways to get processors, either through downloading open source, building your own, or licensing them from one of the new RISC-V processor vendors. So really there's two types of developer. People that want to take RISC-V and add custom instructions, and then people that just want to take a regular core and use it as is. Now within the ecosystem of RISC-V, compliance ensures software compatibility depending on whichever range you choose. The talk today, we're going to focus on custom instructions. So traditional ISAs have a limited choice. It's a fixed ISA, fixed instructions. With RISC-V, we're now able to instantiate custom instructions. So you can choose your processor as your starting point, you can add your architecture, and you verify your design. So the importance of adding a custom instruction is to evaluate the processor performance. How well does your application run in a standard configuration? And then if you build a custom instruction, how does that benefit your application? That's the essence of why you want to look at a custom instruction. So this is about the design flow. You'll take a target application, your full code, and profile and analyze a module that you believe will be a good candidate for these custom instructions. So this is the high-level concept. Characterize your C application, develop a candidate as a new instruction, initialize that instruction, and then you would repeat maybe a loop to verify and approve. Once you've established the specification of your instruction, you then optimize it and develop the documentation, and then release to your audience, your developers, your apps developers, your wider ecosystem. So within Imperas, we have an instruction set simulator that models the entire architecture of RISC-V. This then allows you to add on your custom instruction as a C file. This is our development environment, which supports all the debug and analysis tools that you'll need as you profile your application and debug your application, basically the starting point, and then when you have your custom instruction. So this is a bit more detail now. So you take your C application, you're going to run an instruction accurate simulation, look at the trace and the debug, timing and profiling of your basic application, and look for hotspots and areas that you want to optimize. This is an example. We've worked with a security company developing some custom instructions for the CHA-20 algorithm, which is very well known within security. This is a good candidate of some C code that could run as a standard architecture or with custom instructions. So we take the C code and we use that as a starting point to estimate the performance as a custom instruction. And then we look at the comparisons. Where are the hotspots? Where are the routines? Where are the time spent looking at your way your code operates? So again, now we're looking at the new target instruction, how well that would affect your performance and how well that would run in your application. So we add the timing and the performance to the model. Now we've got the code we can run, we can look at the 4 candidate instructions, cross-simulation, and look at the simulation results. When we add the new instructions, we can see that we get the same compile environment, but we can now get a single instruction. We can also add approximate timing for the simulation of these models. As you look at the cycles that are taken to run your code through, you can assign a timing characteristic which allows you to further tune and further optimize as you tune your development. We can also run a full trace, look at the full diagnostic of all your application code running. This can be the complete code, not just the custom instructions. And of course, no software is complete without mentioning debug. There is always a need to look at your code, analyze as you understand the interaction of what's happening, both with your original code and now with your custom instruction. So we profile the new code to make sure that the custom instructions are utilized as we expected. And we can then look at the block running of the whole code. This is an iterative loop that you may repeat more times than I'm doing here in this presentation. Once you've established the candidate instructions you want to move forward, then there's a case to write the documentation and build the final C model that you want to give to all of your developers. Yes. We also have further analysis tools to look at the line coverage and code coverage to make sure all of your instructions are fully exercised, and we can run compliance testing as well. And we can also profile the full application to make sure it's using the applications and the instructions that you developed. And automatically, from our system, we develop the documentation. This is important to hand off from the initial developer to your application developers so they can make use of these new instructions in future code. And then finally, this is now the stage where you want to release and deploy to all your application developers, either internally to your company or your partners or the wider ecosystem. So in summary, within RISC-V, custom instructions add a lot of value, add a lot of flexibility, but it's important to tune your full application to look at the way these instructions impact and support your whole development. Using an instruction-accurate model allows you to run your full application code, retain compliance, and do all of your testing and analysis. So thank you. My name's Kevin McDermott, and we have some more information on our website. Please enjoy your t-shirts, and I'll take any questions.